All right, hey everybody, welcome to chapter 9. In this chapter, we're going to be looking at hypothesis testing and learning how to write these and learning how to prove them. And this is kind of the backbone of a lot of the statistics course. Up to now, we've been working on analyzing data, and now we're going to start putting it all together, and we're going to make conclusions about a data set, and we're going to conclude where we're going to analyze the data and come to a conclusion about it. And to come to a conclusion, we're going to write a hypothesis, and that's going to be testing something regarding that data set. So it's a hypothesis test involving collecting data from a sample, then evaluating that data. Then we make a decision on which side of this we fall. And we're going to have two hypotheses. We're going to have a null hypothesis and then an alternative hypothesis. So to do this, we're going to write two hypotheses. We're going to collect our data. Then we're going to determine what type of data we have and what type of test we need to use. That depends on what information we're given. And we're going to analyze the data using the calculations we've learned up to this point. And then we're going to make a decision and write a conclusion. Okay, and this chapter is going to be looking at some of the more basic examples. And this first chapter is just learning how to write these hypothesis statements. And then in the future chapters, it's going to get into the harder, like two sample data sets. All right, so this quote I think is a really good one. And Carl Sagan is a really pretty neat astronomer from the 70s, really big popularizer of science. And here's his quote: "What counts is not what sounds plausible, not what we like to believe, not what one or two witnesses claim, but only what is supported by hard evidence, rigorously and skeptically examined." And the last sentence is the most important: extraordinary claims require extraordinary evidence. I think that sums up this chapter well. In order to prove our claims, we need really good evidence to back it up. And that's what we're going to be looking for. So really good evidence is going to be, we're going to look at that in regards to probability. And we'll talk a little more about that as we get to it. But just remember that extraordinary claims require extraordinary evidence. All right, so here's the page talking about our two different hypotheses. We have the null hypothesis and the alternative, and they're always opposing each other. So the null hypothesis, it's a statement that about the population that either is believed to be true or is used to put forth an argument unless it can be shown to be incorrect beyond a reasonable doubt. So that's kind of confusing. Basically, when you think about the null hypothesis, that's what kind of the normal would be. The alternative hypothesis is what we want to prove, and the null hypothesis is going to be the opposite of that. So let's think about it this way. The alternative hypothesis is a claim about the population that's contradictory to the HO, or H0, which stands for the null hypothesis. So the alternative hypothesis is going to be what we want to prove, and the null hypothesis will be the opposite of that. Let's look at this with a more basic example coming up next. Okay, and we'll talk about this in a little bit. They're contradictory, and we examine evidence, and we decide whether or not to reject that null hypothesis, and then we make a decision. Okay, let's look at a simplified example. Suppose we want to prove that it's rained in the past 24 hours. And maybe we were out of the States or something, and we weren't sure if it rained here. So what we could do is put out rain gauges to collect water before we leave, and then we go out of town and come back. And we could obviously just look at the rain gauge to determine if it rained. And so to write this out in terms of our hypotheses, we could look here. So The alternative hypothesis, this is what we want to prove. It did rain in the past 24 hours. So therefore, rain in 24 hours is greater than 0. And we could use a variable there, like capital R bigger than 0. And then our null hypothesis would be the opposite of that. So the opposite of more than 0 rain would be 0 or less rain. Well, you can't have negative rain, so we'll just say equals 0. So in words, that would be it did not rain in the past 24 hours. And so what we can do is look at this, and if we can prove the null hypothesis is wrong, so we're always going to look at the null hypothesis. We're going to try to see if we can prove that to be false. And if that's false, so if we can somehow prove that it did rain, so the null hypothesis is wrong, then we could accept the alternative hypothesis. And since these are opposites of each other, if the null hypothesis is wrong, which takes extraordinary evidence to prove that it's wrong, then the alternative will be true. So to do this, we collect data and analyze it. And statistics is going to be a lot more difficult than just looking at a rain gauge. But so we look at the data and we analyze it. And is there water? And this version is simple. Is there water in the rain gauge? Yes, we have data to reject the null hypothesis. Since we reject the null hypothesis, the alternative one must be true. So we accept it. So there we go. There was water in the rain gauge. So we say, yep, it's rained in the past 24 hours. So the hard part here is collecting the data and then analyzing it. And that's what we're going to be looking at later on. So, but this kind of logic, see how these are, you just want to notice that these are opposites of each other. And then we're using that, that process of accepting or rejecting the null hypothesis. And so we write these out using variables. We use this mu, lowercase mu, for single means. And we use a p for single proportions. Then we use HO and HA for our null and alternative hypothesis. So we use H subscript O, or 0, and H subscript A. And to get subscript on Google Docs, you hit Format, and then I think Text and Subscript. All right, so HO or H0, we'll have these items. We're always going to have an equals to, and then our alternative will have these options. So the opposite of equals would be not equal to, or you could use greater than or less than, if in our case where it doesn't make sense to have a negative number. If the null is greater than or equal to, the alternative would be less than. So these are just opposites of each other, examples of that. So here are some examples. Our null hypothesis here: no more than 30% of the registered voters in Santa Clara County voted in the primary election. So no more than, so that means it must be less than or equal to, so P less than or equal to 30. So the opposite of that is more than, so more than 30% of the registered, of the voters voted. So greater than 30. Second one, we want to test whether the average GPA of students in American colleges is different from 2.0 out of 4.0. So the null is if it wasn't changed, and the alternative is what we want to prove. So we want to prove if it's different from 2.0. So therefore, the alternative is going to be the mean is different, so not equal to 2.0. And the null would be the opposite of that, equal to 2.0. We want to test if a college takes less than 5 years to graduate from college. So remember, the alternative is always what we want to prove. So average is less than 5 years. The null would be average is bigger than or equal to 5 years. And then we would see what the data shows us. All right, so for these, we're going to be attempting to write some of these for our homeworks. Remember, the alternative is what you want to prove. So Like this one, we want to determine whether or not a new medicine reduces cholesterol by 25%. So that would be, we could use a variable here, like R equals 25% reduction. So R equals 25. That would be our alternative, and the null would be R doesn't equal 25. Maybe it reduces it by more than 25, or maybe it reduces it by less than 25, but it's not 25. So down here, we want to find the average height of 8th graders, 66 inches. So whether the mean height of 8th graders is 66 inches. So remember, we always put the equals in the null hypothesis. So that would be mu, or our average, equals 66. And here, alternative, average doesn't equal 66. So just equals and doesn't equal. Test if it takes fewer than 45 minutes to teach a lesson plan. So test if it takes fewer than 45 minutes. So that's what we want to test. So alternative, mu would be less than 45, and the null would be greater than or equal to 45. And about 40% passed the test on the first try. We want to see if more than 40% test on the first try. So more than 40%, that's what we want to test. So this on the alternative would be P is greater than 0.4. And then up top would be P is less than or equal to 0.4. All right. Hopefully that helps you get started on this section.